Dumb. Let's see, -1/2, C -3, D -8 to the second, and then I've got -6 C2 D3. So, ask me what you asked me about the negatives before I work it. Oh, okay. Y'all still want me to work this one? No? Okay.
My question was on number 21. Like, I got the right answer, but on the top, it's 18 times squared plus 3x. Can you not take 2 out of that?
Yes.
Well, see, that's what I was going to, but the answer key didn't do that. The answer key, it didn't factor all the way.
Okay, well, y'all make sure to factor all the way. That was the one that came with this.
Because now I'm confused. Like,
21, you said? You want me to work it?
well, no, no. It was an easy problem. So I just noted it.
Yeah.
But did you factor some up here on this one? Wait, no, because there's nothing that adds to that working problem. It's like in this simple like
Which one did you say? 3. I would probably work inside here before I took that 3 to everything, but you don't necessarily have to. It doesn't matter. I would probably go down and up here. And so you get, let's see, that would give me 10 Q's up top. And then on the bottom, 3P7. Is that skipping too many steps? But whenever it moves up, it becomes positive. So then I'd have Q2 up here, and when I add them together, that gives me 10. So now the 3 goes to everybody, so it'd be Q30, 3 to the third, P to the 21. Okay, so what'd you do, distribute first? Okay, so you have P -3, Q24 over 3 P 18 Q -6, right? And then we'll start moving everything around. So I'll have Q20. Oh, that's where you messed up. Which very well could have been Christina's question about the signs and stuff. When they moved it, they didn't change the sign.
Oh, yeah, I had to rework it.
Okay.
I wrote it wrong.
What else? 24. Here's the top. And there's the bottom. All right, what's the what's the LCD up top? You got 6 and 3P squared. 6P squared, so says Brian, he is correct. So this one needs a P squared. This one needs a 2. So I end up with P squared minus 16 over 6P squared. And I'm going to go ahead and factor that down. P minus 4, P plus 4 over 6P squared. It's late start tomorrow. And then the bottom, LCD 2P. So this one needs a 2, this one needs a P. I have 4 minus P over 2P. And now I just put them together. I don't remember who asked for this one. Top, here's the top, and then I'm going to flip the bottom. 2P over 4 minus P. Ooh.
Oh, yeah.
Oh. Okay, so P cancels 2. This becomes 3. All right, so look what I have. I have P minus 4, P plus 4, over 3p4 minus p. What do you notice? That's right. Why? These are exactly the same. The only difference is they have completely opposite signs. The p is positive, here is negative, the 4 is negative, the 4 is positive. So I take a negative 1 out, and they cancel, or I can cancel, and it leaves me with negative 1 p plus 4 over 3p. It leaves the negative 1. If you take a negative 1 out, it becomes, yeah,
Wait, so why is there a negative 1 on the top?
it doesn't matter where you put it. You could have put it, this is the same thing as this.
Okay, that's all right.
Or
That's what I
that. Yeah, all those are the same.
Alright.
Ready, Freddy's?
Yeah. I think I was confused on the taking the negative 1 out. I don't know. Like, I don't think I understood that you were like taking the negative 1 out.
Figuring it out.
Yeah.
Right.
I was just like, oh. I think I was thinking about you multiplying it by negative 1.
I gotcha. All right, last day on rational equations until we actually graph them, and then you'll cry. I'm just kidding. But you might, but I'm just kidding. Not today, though. At least it's not today. All right. Brian's a little mellow today. He's starting to scare me a little bit. I know. We're working this out, yeah.
Nah. I don't care. I don't care.
So, if you like the guided notes, there's some little guided notes up there. I don't really solve my rational equations that way. I always solve them the same way. But if you like method 1 of proportions, you are more than welcome to use it. So here's what we're going to do. We have rational expressions, right? Like look at number 1. V minus 4 over 10 equals V plus 3 over 4. If you need to solve that for V, what would your first instinct be to do there? Okay, here's what I do with these. Because there's just one fraction equals one fraction, which is a proportion, right? That's what proportion means, two ratios set equal to each other. You could go through, nobody said it, but you could cross multiply and set them equal to each other. I do not usually do that method. I usually do the method that always works, and here's what that is. You find an LCD. I'm going to say find and force LCD to all fractions. Okay, what do I mean by force LCD? Make them all have the same denominator. Once that happens, solving's easy because all you do then is drop the denominators because they no longer matter since they're all the same, and solve using only the numerators. That is my preferred method. Now, if you want to cross multiply on this one, knock yourself out. Sometimes it ends up being the same thing, sometimes it doesn't. But let me show you how LCD method works, and then I think you'll like it the best. I think it'll be the best way. You have to do it if it's more than just a proportion. So if you get ones that look like number 5 or number 6, you don't have a choice, unless you want to simplify first and then, so whatever. All right, looking at these two fractions, what is the least common denominator of 10 and 4? 40, right? Oh, 20. 20, I could do 20. It doesn't matter, you'll just have a little more work. But let's say, all right, let's say 20. What does the first one need? 2. So I give it here, I give it here. What does this one need? A 5. I give it here and I give it here. Now because the bottoms are exactly the same, they're both 20, right? I can just go, forget them, and just look at the top. 2 times V minus 4 equals 5 times V plus 3. I know y'all can solve that. That's a linear equation. It's that easy. Well, yeah, we will now. We'll solve. We'll go through 2v minus. What happens if you what? Yeah. So they'll solve it. But that's it, yeah.
It's just, it's just, I have to be, like, negative's not be equal. Yeah.
Y'all are looking at it going, okay, there's a catch here somewhere. What? I'm so confused because it's easy. What the heck did you do?
Is that what you're doing the whole time?
Oh, I know how to do
Oh gosh, I know how to do that. Y'all, that's so good.
Okay, the only I just ran now they're not all this easy. I just ran the first one for us to have some examples to work through as notes. Okay, before we get to 6, let's do number 4. So remember, one helpful hint too is to always factor if you can before you start anything. That's all. Yes.
There's no air conditioner on.
Okay. What is the LCD? I'm gonna put them together. I'm gonna say 2 times b plus 6. Guys. All right, yes, I would just leave it like that. I would leave it like that. Don't remember, once things are factored down, don't expand them. And that's completely factored out, yeah. Okay, so what's the first one need?
B plus 6.
What's the second one need? Are the bottoms the same? Drop them.
So you literally can just like copy them.
Yes. Okay, but it gets, look, now, look what I have. I've got the foil. I'm going to end up with a quadratic. That's okay.
I love foiling.
I don't like foiling because Miss McHale. She never explained it to me, so I never had to do it.
Who, I didn't?
No, Miss McHale.
I don't like foiling because I always do it wrong.
I supposed to work.
I just feel.
Okay, well, so just take every piece in this and distribute. Yeah. B times 2B.
I do the box.
And I'm going to go ahead and distribute on the right side too, because the difference now is I'm solving, right? So I do need to expand some stuff out.
So now it has to be equal. Wait, what's that thing?
Did the what? What 12? Oh, yeah. Sorry. All right, so I'm going to clean it up a little bit. 7b minus 30 equals 8b minus 2. I'm going to make it equal 0 since it is that's where y'all say quadratic. I'm going to make it equal 0. So I'm going to subtract the 8b. I'm going to add the 2. So I have 2b squared minus b minus 28. Yep. And now, how do I solve a quadratic? Or factor. Your favorite F word. I said that while I was getting observed last semester. And y'all know how nervous I get when I'm getting observed anyway. And I was like, okay, what do we do with the quadratic? It's equal to 0. It's your favorite F word. And everyone went, you really want us to say it? And I was like, oh gosh, Stacy. Okay. So your favorite F word is factor. So what multiplies to negative 56b squared but adds to negative 1b, 8, and 7. There you go. No, 7 and 8. So 2b squared minus 8b plus 7b minus 28 equals 0. And then I take out a 2b, it leaves me with b minus 4. And then I take out a 7, and it leaves me with b minus 4. And I get b minus 4 times 2b plus 7 equals 0. So what are my two solutions?
That's right. I remember getting
Good. I'm glad you remember this. That's good. Just solve it, yeah. Look at number 7. Try number 7 on your own. We'll see what happens. Make sure you find the right LCD.
Okay, for all of them, right?
Yeah. Seven. I'm gonna let y'all try 7 for a minute, and then we're gonna do it together. I bet I have an answer.
Bro, I swear to God.
What's your question?
I don't know if it's hard to
Yes.
No, I was trying to help you.
It was a statement.
Well, I didn't know if it could because we've always done like 4 things with the LC.
They can. Don't look up until you finish.
That's what I got.
I did the wrong question. I did it wrong.
No crumbs.
Bro.
I didn't get negative.
What? Oh, that's the LCD. Sure. So you'll find a lot of ways to do it. This is just my favorite way to do it. You could combine both of them together on that left side first, and then go through and do LCD. Whichever's fine. You're ending up doing the same thing. I just like one step instead of one. I'm just lazy. No, I'm just. Where you see V?
Why would you have a B when the variable is off? Okay, but can you use your comment? Why would you think it was
Yep. Okay, try number 8. Go ahead, Madison. What's your question? Yeah. They don't have the R, right? So I really did this. I did minus 15R and plus 1 all at the same time. 8. I can't wait to do 8. It looks fun. They're when you know how to do them. What, Aaron? Really, what, Aaron?
Your mom. I was gonna say about the same thing as that, and I realized it's very happy. I just don't know.
Are we supposed to be doing Aaron?
Oh, I'm glad that. Oh my gosh, wait. Why did that space close? Oh my gosh, you can cancel this out.
Don't look before you've tried it.
Are we trying for it, bro?
You're just trying to solve for K. No crumbs. When we take a test on this. It'll be soon because it's just so. This is really the last of the review stuff. We'll probably take tomorrow and kind of review over the review stuff and see if there's anything, any holes or anything like that that we need to fill. I won't be here Friday though. I already told y'all. The recorder. I was just making sure I picked it all up. You still could. It's just gonna be.
I don't know how to.
You're just making more work.
Just add them all.
All right, y'all ready to kick it up a notch? Oh, wait.
Let's do it now.
Okay. Just since you said so, the second page. No. This is just examples for us to work through. If you know how to do it, yeah. We're going to do a couple a little bit harder ones. But
So with these ones, you just don't ever simplify them?
no, I would start by finding LCDs. So it might be the bottoms that you need to factor, but not so much the top. Like, for instance, on number 9.
Number 9?
If I need to find the LCD here, right? Before I find LCD, I want to factor the bottoms. So
Why can't you just literally make it n minus m?
you could just multiply by m. It's the same thing.
Okay, I'm good.
Okay, well, it's just m times m minus 1 is all I'm getting at. You're factoring, you're just doing it in your head. And you're going, oh, I see that all I need for this one is an m to make everybody look the same. Right? What?
I don't know. To me, that's just
Okay, if it's like that, but look at like 13. Because see, whenever it's like 13, you'll really want to factor that quadratic first, because otherwise you're going to get in a sticky situation. You see what I'm saying? Right.
I'm probably gonna add a lot of stuff in harder. So, what was the answer for?
And if you go to eight, I got this page.
One more. If you got it, I'll shut up and let you just do your homework. 13. And remember, if you have a whole number like number 12, or you just have W, or you just have a number, that's over 1. And so you'll make the bottom be the whole LCD. But yeah, work on 13. Let's see what happens. No, just the second page. This is just, y'all said you liked the guided notes and stuff, so I just ran it. I didn't run it for them last semester. I just gave them page 2. But if I did, I made them do it for classwork and not because they wouldn't work.
So what do you do when you
Who doesn't understand factoring?
I don't understand the I don't understand what you do with that.
Okay, so
That's what's fantastic.
the leading coefficient is 1, right? The leading coefficient is 1, so I can shortcut it. So tell me the two numbers that multiply to 10 but add to -7. Right? So because it's a 1 in front, I can shortcut it and I can say, okay, -5 and -2. It's that easy when there's a 1 coefficient, leading coefficient. What do you mean you don't know how?
I don't know how to get the 2 to get 2 times 1. And then everything times 2?
Yeah, so put your LCD all together. So write the first denominator, z minus 5. Now go to the second denominator. I have a z minus 5, I need a z minus 2, right? Now the last denominator has just 2, so I need to make sure I include it. Remember, you have to get them all to look exactly alike. So what do I need to combine so that I can multiply them by something to make them all the same?
Now, what do you do for 2? You add a z minus 5 and a negative 2.
You add all of this because it's already got the 2. So it's going to get a z minus 5 and a z minus 2. Yep. So this one needs a 2. This one doesn't just need a 2, it needs a 2 and a z minus 2. And be very, very careful whenever you go to solve this one because of this subtraction sign here. So if you want to think about it as plus -1 and have that -1 multiply, or you can look at it as minus all of this. The 5 and the 2? So if you change it to like this, it would make this first one become -z plus 5, and then you could just FOIL it with the z minus 2. Don't distribute it to all of them whenever you're multiplying like that, because remember, you only multiply 2 at a time. When this, put a line through your z so you can.
Well, I put a line.
Let me show you. What parentheses are you talking about? Well, don't worry about the bottom.
You're not simplifying one side.
You don't have to. Which, I mean, whatever way is easiest for you. All right, 2z minus 4.
The -1 sign between the two different change all the signs.
Yes. Now, it changes all the signs if you multiply first and then distribute the minus. You see what I'm saying? But don't come here and go negative, positive, because it wouldn't change all of them like that. You'd have to multiply first, because here's why. If you have -1 times this, you can't multiply more than 2 things at a time. So you couldn't do more than 2 at a time. It wouldn't go -1 times this and -1 times this.
It was from the minus.
Yeah, I was saying you could make this negative up top and distribute. I look at it as I'm subtracting all of this. So I'll work inside first and then I'll subtract everything. Yeah, that's what I would do. That's what, yeah. I keep this minus sign here and I go z squared minus 2z minus 5z plus 10.
Oh, wait.
Can't do it just yet. 2z minus 4. Z squared minus 7z plus 10. Now I can change all the signs in there. Now, if you changed it in the beginning, I think Lainey changed it in the beginning. You don't have to go back and change it now. You've got a plus. Some of us didn't know. Like plus 7z minus 10. This negative, it's subtracting this, it's subtracting this, and it's subtracting this. So minus -7 is plus, and minus +10 is minus 10. You're subtracting all of that in parentheses. Okay, so from here, I have a quadratic, get everything on the same side. But keep your squared term positive. So move everything so that your squared term's positive. So I would probably move this z squared over here and get everybody on that side. So z squared, subtract the 7z, minus 5z. Go ahead. Oh, yes, I'm sorry. 2 minus 10 would be -8. Sorry. That'd be plus 4. Because this 2 in front combines with that 10 on the end. Yep. Because it's got that squared term in it, so I know it's a quadratic. And anytime I have a quadratic, I want to make them equal 0. So 2 solutions, 1 and 4. You could, but you got a quadratic. So if you got a quadratic, you want it to equal 0. So you can factor it.
I'm already doing the freaking bedroom class. Why am I answering the song?
Probably not.
That is literally
Literally that class. It's
Is that what y'all say about my class too?
Yeah.
All this busy work?
It's actually I feel like I'm learning. We're not class. It literally says filler class. She literally says this isn't a content class.